Hello, my friends. Thank you very much for subscribing to our channel. Given any 6 consecutive natural numbers, from n to n plus 5, there is always a prime number m, so that one of these 6 natural numbers, and only one of them, is divisible by m. How to prove it? Why not give a try, and we will come back soon. Let's take a look at what this statement actually means by using 2 examples. If the 6 natural numbers are from 1 to 6, we list all the prime factors of each number. 2 is a factor of 2, 4, and 6. So it's not the m we're looking for. 3 is a factor of both 3 and 6. So it isn't either. The prime factor 5 is only the factor of 5 itself. So m can be equal to 5 in this example. In the next example, the 6 natural numbers are from 11 to 16. We list all the prime factors. 2? No. 3? Doesn't work either. M can be 5, 7, 11, or 13. These 2 simple examples give us an idea of what this statement means. But unfortunately, they can easily puzzle us as well. Since m can be 5 in both examples, so is 5 our target? Of course not. If we choose the 6 natural numbers from 10 to 15, obviously, there are 2 numbers that are divisible by 5. M can only be 7, 11, or 13 in this case. We can randomly choose an m. For example 11. And let's take a look at what features it has. 11 is bigger than 6. If there is one number from this sequence that is divisible by 11, we can indicate it as n plus I, where I is between 0 and 5. Then the previous and next integers, that can be divisible by 11, are n plus I minus 11, and n plus I plus 11 respectively. Obviously, I minus 11 is smaller than 0, and I plus 11 is bigger than 5. So neither of these 2 numbers is in the given 6 consecutive natural numbers. So the conclusion is that, if any of these 6 consecutive natural numbers is divisible by any prime number that is bigger than 6, then this prime number that is bigger than 6 can be the m we are looking for. So, how can we prove that there exists one out of the 6 consecutive natural numbers that can be divisible by a prime number bigger than 6? We know that there are only 3 prime numbers that are not bigger than 6, and they are 2, 3, and 5. So we only need to prove that, among these 6 consecutive natural numbers, the amount of those which are divisible by at least one of 2, 3, and 5 is smaller than 6. Of course, there is an exception, which we'll get back to later. How to calculate the amount of those which are divisible by at least one of 2, 3, and 5. We can calculate each case separately, and finally calculate their union. Let's first look at the case of 2. The remainders of the consecutive natural numbers dividing by 2 must be in the manner of 1, 0, 1, 0, alternately. So no matter how we choose these 6 consecutive natural numbers, there must be 3, and only 3 of them that are divisible by 2. In the same way, there must be 2, and only 2 numbers that are divisible by 3. Their summation is 5. But, please don't forget, there is one and only one of them that is divisible by 6. That is, it is divisible by both 2 and 3 at the same time. So the amount of the numbers that are divisible by at least one of 2 and 3 is 4. The amount of the numbers that are divisible by 5 can be 1 or 2. In the case of 2, one of consecutive the 2 numbers that are divisible by 5 must be divisible by 2. So the amount of the new numbers is at most 1. The statement of at most here depends on whether the number that is divisible by 5 but not divisible by 2 is divisible by 3. In any case, the final amount really won't be bigger than 5. Let's now go back to the exceptional case we talked about earlier. In general, that at most 5 out of the 6 consecutive natural numbers are divisible by at least one of 2, 3, and 5. Already indicates that, no matter the rest is prime or composite, it is always divisible by a prime that is bigger than 6. However, what if the rest one is neither prime nor composite? So the only exception to this is the case where the 6 consecutive natural numbers are from 1 to 6. There are indeed 5 numbers that are divisible by at least one of 2, 3, and 5. But the rest one is indeed 1. Fortunately, there is only one number that is divisible by 5. So there is still no problem with the final conclusion. Thank you for watching, and see you next time.